So our next experiment is frequency modulation. The objective of this experiment is to perform frequency modulation in time domain using Scilab. Equipments, Scilab software as usual. Now frequency modulation, we have to just know something about the frequency modulation. In FM or frequency modulation, the phase angle of the carrier signal, which is AC cos 2 pi fct, is varied proportionally to the integral of the message signal of, that is f of x of t. The frequency modulated signal is fxc of t, which is given by this formula here. The kf is a constant, which is the instantaneous frequency of the FM signal, and which is given by formula here. In this special case, the tone modulated FM, the signal, message signal, is sinusoidal, which is given in this formula. There are various formulas given here, and the parameter, beta parameter, is an important factor in frequency modulation. The example is the plotting of the frequency modulation using the time domain. Now, this is a code which is pre-installed, pre-written, and all the parameters are reloaded into it. Now, we'll just run it. Before running it, let's see what are these. It is a time interval, the amplitude of the carrier signal, the amplitude of the modulating signal, the carrier frequency, the modulating frequency, the formula of the carrier signal, the modulating signal, the frequency modulation signal, the modulation index, the most important factor here. And now we will plot a graph. With the modulation signal as 1, we get this kind of graph. Okay, so this is the modulating signal, this is the carrier signal. Modulating signal and the carrier signal are superimposed with each other with some phase of angle, and in return we get a frequency modulation. Now let's change the modulation a little bit. Since changing the modulation little bit won't affect the frequency of the modulating signal, frequency modulating signal, but since we have to change something, then we will change modulating signal. Let's make it 2. We'll save it and execute it. Now the modulating signal has been decreased, as we can see here, frequency modulation. Now we'll change it again and make it 3. We'll save and execute it again. Now as we can see, the frequency modulation is changing as the modulating index is changed.